Today in class, we're going to need our 9.3 packet, and we're going to flip to Thursday's page in the packet. Typically on Thursdays, we do a quiz review to prepare for the quiz that we're going to have on Friday. But this week, we don't have a quiz on Friday. So instead of doing a quiz review, we're just going to do some more practice. So this is kind of a lightweight assignment to practice the skills we were working on yesterday. Take a look at the top of the Thursday page. The instructions say, solve the following quadratic equations by factoring. And this word is what I want to point out. It says solve. So this problem is a little bit different than the examples we were working on yesterday. Specifically, it wants us to find solutions. That's what solve means. Find solutions. That word solutions should ring a bell. Thinking about quadratic equations, can anybody think of another word that we use to describe the solutions of a quadratic equation? Roots. That's the one I was looking for. The solutions of a quadratic equation are the roots. We also sometimes call them zeros, and we sometimes call them x-intercepts. The name zero comes from this right here, because these are the numbers that you get when your equation is equal to zero. But roots is the word that we've been using the most in class, so that's what I'm going to call them today. So when the instructions say solve, that means we need to find solutions, which means we need to, aka, find roots. We're going to find the roots by factoring. And if you think back to Monday, or if you flip back to Monday, even better, and you look at the very top of Monday's page in the packet, there's a list of when the standard form is better and when the factored form is better. Pretty much the only situation where the factored form is better is when we want to find the roots. And that's what we're doing in these examples. We want to find the roots, so we need to use our factored form. So that's why we're going to factor. And that's the skill we practiced yesterday, was the factoring part. But the rest of it will be a little bit new to us. So let's do, what I'd like to do today, I think, is do at least a couple of these together. Like maybe we could do example 1 together and example 3 together, and then I'll let you loose on the problems to work on the rest of them on your own. There are 8 problems on this page, but if you flip to the next page, you'll see there are a few more problems on the back. These are challenge problems. They're a little tougher, and they incorporate something that we haven't actually talked about yet. So we'll do a couple of examples together, and then I'll let you work on the rest of these on your own. And if you get to the practice, or if you get to the challenge problems today, see if you can solve those on your own with the hint that's provided at the top of the page. Okay, let's dive into number 1. In number 1, we need to find the roots, find the solutions. And in order to do that, we want to convert this quadratic equation into the factored form. Factoring is kind of the opposite of multiplying, so we're going to start with a generic rectangle. Into our generic rectangle, we're going to put the x squared on the top left, and we're going to put the positive 3 on the bottom right. Then we do what we can to figure out what factors would go on the outside. And that'll help us figure out the rest of our box here. So on the outside, our factors are both going to need to start with x. That's the only way we can get x squared in that top left box, is if we have x times x. Then we need to look at these 2 blanks here that I'm circling in green. These 2 blanks need to be numbers, and they need to be numbers that multiply together to give us positive 3. So first, let's think about the sign. If they multiply together to give you a positive 3, then either both of our numbers have to be pluses or both of our numbers have to be minuses. It's going to be one or the other. They have to both be the same, because that's the only way to get a positive number out when you multiply. Now let's think about the numbers. If they multiply together to give you 3, really the only option is 1 times 3. I can't think of anything else that multiplies together to give me 3. So I'm going to go ahead and fill in the 1 times 3. That part's easy. Now let's think about our signs. Do we want 2 positives or do we want 2 negatives? That's where this middle term comes in. We want to have a plus 4x. So we need the 3x and the 1x to both be positive numbers. That way when they add together, we get a positive 4x. And that's basically the logic we follow. So we're going to get a positive 3 and a positive 1. So we have factored, but we are not done. Remember, the goal is to find the solutions, find the roots. So what we're going to do next is we're going to write this quadratic in factored form. So that looks like this. X plus 3 in parentheses times x plus 1 in parentheses equals 0. So I just took this part of my quadratic equation and I turned it into a factored form. But notice we still have the equals 0 over here on the right. That stays there. We don't just get rid of that because we factored. That's still part of our equation. So now look at what we have. In our factored form, we have 2 factors being multiplied together that equal 0. We've talked about this many times. I've mentioned this before. If 2 things are multiplied together and that equals 0, what do we know about those 2 things that are being multiplied together? We know that one of them has to be 0. One of them has to be 0. So that's why we don't know which one has to be 0, so we split it up into 2 separate possibilities. It could be the first factor that's equal to 0, or it could be the second factor that's equal to 0. So we're going to split this up into 2 separate little equations. Maybe it's the x plus 3 that equals 0. Maybe it's the x plus 1 that equals 0. And we need to solve them each. But that's the easy part. These are both quite simple to solve. We just subtract 3 for the first one, and we subtract 1 for the second one. We end up with 2 roots. Our 2 roots are x minus 3 and x equals minus 1. So minus 3 and minus 1. Now, does anybody remember before break, we did a little bit of practice with finding roots, and we noticed a pattern. If your factor has an x plus 3, you end up with the root minus 3. And if your factor has an x plus 1, you end up with the root minus 1. Remember that pattern we talked about? That pattern's going to come up today a lot. So if you remember that pattern and you know how it works, you can kind of skip some of this work over here on the right. You don't have to do all of this work where you split it up into 2 separate equations and solve each one for x. Most of us can just look at these and see the correct answer. Now, you can write out all the work if you'd like to, but if you're starting to feel comfortable with that pattern, feel free to kind of skip ahead. All right, are there any questions about this first example? I want to do another one together as a class, but I don't want to do number 2. Let's see, what do I want to do? Let's do number 3 together. So take a look at the problem below, the one we just did. We're going to use a very, very similar process here. We need to convert this into factored form in order to find the roots. So we're going to start with a generic rectangle, split it up into a 2x2 grid, and fill in what we know. Our x squared goes in the top left, and minus 2 goes in the bottom right. Be careful, that is a negative 2, so we have to put the negative sign in there with the 2 when we put it into the box. Now let's start building our factors. Our factors are both going to start with an x. That's because that's the only way to get x squared in that top left box. But now let's think about the numbers that would need to go into the other blanks. These two numbers have to multiply together to give us a -2. So think about your signs. If they multiply together to give you a negative, that means one of them has to be a positive and the other one has to be a negative. There's no other choice. We're going to have to figure out which one is the positive and which one is the negative, but we know it's going to be 1 and 1. All right, now let's talk about our numbers. Numerically, we need two things that multiply together to give us 2. The only option is 1 times 2. So let's go ahead, since we know that it's 1 and 2, let's go ahead and write those in and try to figure out which one gets which sign. So we know one of them is going to be a plus and the other one's going to be a minus. And we need these two things to add together to give us a positive x. And it might help us to think of it not as a positive x, but as a positive 1x. So when you're thinking about your 2x and your 1x that are here in our grid, which one of those do we want to make positive? The 2 or the 1? Any thoughts? Nevaeh. The 2. Can you explain why? Because it's the biggest number. Okay, I really like where you're going with this. So I just want to point this out to the rest of the class. When you have a negative number in the bottom right box, we're not going to be looking for a sum to make up the middle piece. We're going to be looking for a difference to make up the middle piece. So the difference between 1 and 2 is 1. And it's the bigger number that ends up controlling the sign. So if the bigger number is positive, you should have a positive in the middle there. If your bigger number is negative, you should have a negative number. So I love that you guys are starting to pick up on things like this. So pay attention to patterns like the one Nevaeh just mentioned. Great job. These patterns are going to help us solve these problems more quickly. So we're not quite done with number 3 yet. Now we need to actually find the roots. So we're going to take our factors and write our expression in factored form. So x plus 2 times x minus 1 equals 0. And at this point, we could split this up into 2 separate equations and solve both of them, or we could use our little shortcut. I'm going to use the shortcut. One of our factors is an x plus 2, so I know that one of my roots is going to be a minus 2. And my other factor is an x minus 1, so I know my other root is going to be a positive 1. There we go. I think that's all I want to do together at the start of class here. So why don't you start working on the rest of these problems on your own. I'll be around to answer questions. I'll help you guys out. I'll check your work. And if you finish up, give the challenge problems a try on the next page. I'm curious to see how you guys might do with that. And if you want a little bit of a hint, raise your hand and I'll come help you out. And then toward the end of class, maybe in the last 20 minutes or so, we'll come back together as a class and I'll run through the rest of these examples real quick so that you can check your answers and make sure you have all the correct work. Okay, students, I haven't had a chance to walk around and check everyone's work, but I am getting a very great impression about how well you guys are doing on this stuff as a class. So here is what I want to do. We have, 10:20. We've got about 15 minutes left of class. So I am going to quickly do the numbers on the first page because pretty much everybody was getting these right. I don't think you need me to beat a dead horse. All I need to do here is pretty much show you the answer, and I think you can figure it out for yourself. So I'm going to do 2, 4, 5, 6, 7, and 8 really fast. Here we go, speed round. For number 2, we're going to start with an x squared and a positive 24 in our rectangle. And our factors are both going to start off with x. Let's make a list of numbers that multiply together to give us 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Our 24 is positive, so they're either both pluses or they're both minuses. In this situation, we're definitely going to want two positives. So we need two positive numbers that add together to give us 11. That leads us to positive 3 and positive 8. So our factors are x plus 3 times x plus 8 equals 0, which gives us the roots negative 3 and negative 8. So check your own work against mine. Make sure you got this right. Number 4, we start off with our generic rectangle and we fill it in with the x squared and the negative 27. That negative is going to change things. So let's start with our factors. They both begin with x. And for the 27, we're either going to have 1 times 27 or 3 times 9. And if you have trouble making a list of numbers that multiply together, use your calculator. This is a tool available to you all times when you're in this class. So use your calculator to figure out what numbers multiply together to give you your number. Okay, I mentioned that negative sign. That's going to become important in this problem. For our negative sign, we know that we're going to have 1 plus and 1 minus, because when they multiply together, they give us a negative. What that means is that for our middle term here, we're not going to get a sum, we're going to get a difference. So we need to look down our list for numbers that have a difference of 6. And that's why we pick 3 and 9. So we'll have a 3 and a 9, and we need to choose which one's positive and which one's negative. Since they add together to give us a positive number, we need to make the bigger one a plus. So 9 is plus. And that's thanks to the logic that Nevaeh helped us with earlier. Make your bigger number a positive. So if we write out our factors, there'll be x plus 9 times x minus 3 equals 0. And we end up with two roots, negative 9 and positive 3. You guys all did really well on this problem. I was quite impressed. I feel like the ones with a negative number in the bottom right box are the tougher problems, and I think you guys are all doing very, very well on these. Let's take a peek at number 5. In number 5, we're going to start with our rectangle, throw an x squared in the top left, and a positive 21 in the bottom right. The positive 21 is going to be made up of either 1 times 21 or 3 times 7. And since it's a positive 21, it's either going to be made up of two positives multiplied together or two negatives multiplied together. But take a peek at this middle term. It's negative. So that means we have to have some negatives in here somewhere. So the option we're going to choose is the negative negative. So we're going to have a minus minus. And since the signs are both the same, when we combine our numbers, they would add together. So if we had a negative 3 and a negative 7, they would add together. So that continues our pattern. When the number in the bottom right is positive, you're looking for an additive pattern when you select from your list. When the number in the bottom right corner is negative, you're looking for a difference pattern, a subtractive pattern, to find which two numbers to choose off your list. All right, enough gabbing. Let me finish this out. X minus 7 times x minus 3 equals 0. And we end up with two roots, positive 7 and positive 3. Number 6. In this rectangle, we'll put our x squared on the top left, and on the bottom right, we will have a negative 20. Pay attention to that negative. Let's make a list of numbers that multiply together to give us 20. 1 times 20, 2 times 10, 4 times 5. And now let's pay attention to that sign. If they multiply together to give me a negative, we know that one of our signs will be positive and the other sign will be negative. That means we're looking for a difference. We're looking for a difference that gives us negative 1x. A difference that gives us negative 1. So 4 and 5's difference is 1 because they're 1 unit apart, right? The difference between 1 and 20 is 19. The difference between 2 and 10 is 8. The difference between 4 and 5 is 1. So those are the numbers we want to use. Now let's figure out which one should be positive and which one should be negative. The middle term we're trying to end up with is negative, so we want to make the bigger number the negative. So we get x minus 5 times x plus 4, giving us the two roots of x equals 5 and x equals negative 4. Two more problems. X squared plus 10x plus 25. Everything in this problem is positive, so we don't have to worry about negatives in this one. So I'm just going to make my list. 1 times 25 or 5 times 5 are my two options. And I need two numbers that add together to give me 10. So hopefully it's fairly easy to see that we need to use positive 5 and positive 5. So when we write our two factors out, you might notice that they match. That means we're going to get the same root twice. You don't have to write it twice. You do have to write both factors. You know, when you factor it, this is still two separate factors being multiplied together. But since they happen to be the same, you only have to write your answer one time. This would be an example of a quadratic function that only has one root. Remember, sometimes they have two roots, sometimes they have one, sometimes they have 0. Number 8 ends up being pretty similar, actually, but there is a negative involved in this problem, so we'll have to pay attention to that. Let's start with an x squared and a positive 16 and make a list of numbers that multiply together to give us 16. 1 times 16, 2 times 8, 4 times 4. The middle term that we need to end up with is a negative 8x. So when we're trying to decide between using a plus plus or a minus minus, we're going to have to use the minus minus because those negatives have to come from somewhere. So since they're both going to be the same sign, though, we're looking for an additive pattern. We're looking for two numbers that add together to give us 8, even though they're both negative. And that would have to be the 4 and the 4. So we'll use minus 4 and minus 4. And I was really impressed with how well everybody did on this one. So again, you might notice we end up with the same factor twice. You only have to write the root one time. You don't have to repeat it. So again, we just end up with a single root. You guys did great on these. I was very impressed. You did them quickly too. So you're getting pretty fast at this stuff. I noticed that quite a few of you had time to work on some of these challenge problems. By the way, ignore the numbering. It just jumps up to 17. I took these problems from a worksheet and I selected some that were a little later in the pack. So I didn't give you very much guidance on these. There were a few students where I stopped by your desk and I maybe gave you a hint or a nudge. But for the most part, I wanted to see if you could figure this stuff out on your own. We are going to go over this in more detail later in the week, but for right now, I want to show you just a little tip. Everything we did today, did you notice that it started with a 0 on one side? That's a rule. they always have to have 0 on one side before we solve the quadratic for our roots. That's a rule. And think about why that is the case. You might even want to write this down. The definition of a root is the x value when the y value is 0. That's the definition of a root. It's also the definition of an x-intercept. It's the x value when our y value is 0. So like this point or this point. So in order to solve a quadratic equation, you have to put 0 in for y. So you would have like y equals x plus 1 times x plus 2. You would have to put a 0 in for y and solve for x, and that's how you find your roots. That's the process we would have to use. So this is necessary. You have to have a 0 on one side to solve. So take a look at 17. We can't solve this because it doesn't have a 0 on one side. So the very first thing we have to do is get a 0 over there on the right. Currently, there's a 21, but we want that to be a 0. So we're going to subtract 21. But if you do it on the right, you have to do it on the left. You have to make sure your equation stays balanced. So what you end up with on the left is x squared plus 4x minus 21. And on the right, you have an equals 0. Now we can factor. Once you have a 0 on one side, then you can factor. So then we would be looking at our rectangle. We'll put in x squared. We'll put in negative 21. And I think we might have already factored this one earlier in the worksheet. So let's factor this. Let's make a list of numbers that multiply together to give us 21. It's either 1 times 21 or 3 times 7. And since it's a negative 21, we're going to have a plus and a minus. Since our signs have to be different, we are looking for two numbers on this list whose difference is 4. And that would be the 3 and the 7. Their difference is 4. And 7 is bigger, so we need the sign on the 7 to match the sign on the 4x. So we're going to do a plus 7 and a minus 3. So that'll be a 7x and a negative 3x. Those two things do, in fact, add together to give me a positive 4x. So this is all working. Now it's time to rewrite our expression in factored form. Factored form would be x minus 3 times x plus 7 equals 0. And now we can just pull our roots directly out of this. X equals 3, x equals negative 7. So if you figured this problem out on your own, kudos, I'm impressed. If you needed a bit of help, that is fine. I haven't taught you how to do this yet. So now that you know how to do number 17, maybe you could figure out how to do 18 or 19 or 20 on your own. So don't worry, this is not homework, but tomorrow we're going to have a pretty relaxed day. We're going to do a little bit of a review exercise, and I'm going to ask you guys to try the other 3 problems tomorrow. So when we come back to class today, we'll try 18 and 19 and 20, and then do a bit of review, and then maybe do a Kahoot or something with the rest of class time.